Welcome to Accelerated Math 108, Module 11.3, Solving System of Linear Equation by what we so call the addition method or the elimination method. So this is a little bit different methods compared to the graphing and the substitution methods. We only use this particular elimination or addition method when none of the coefficient when none of the variable has coefficient 1. So let's take a look. A lot of my examples here does have coefficient 1, but I can still show you how to use the elimination method as well. So before we begin, the way I'm going to show you how to do this is the way we eliminate like terms. When two terms that have opposite sign but the same coefficient but opposite sign, like if I have a -4 and a +4, in order for these two terms to cancel out, become 0, we will add them. Okay, so term with different sign, okay, two terms with the same coefficient but different sign, we will add them in order to eliminate them. If both terms has the same sign, in order to eliminate them is by subtracting, because subtracting the exact the same thing actually cancel them out. All right, so here are the procedure or steps that I get from the textbook. It says write the equation in standard form, one under the other, so the like terms are aligned. Multiply all the terms by one equation. Multiply all terms of one equation by a constant so that two like terms have opposite coefficients. This step number 2, I actually do not try to make them into opposite coefficients. As long as they have different signs, I will add them to eliminate. If the two coefficients have the same sign, we will subtract. Because the way the textbook is trying to show us is by the addition method. Addition method simply means when the two coefficients have different sign, we will add them. So step number 3, add the two equations by combining like terms. Here we will add or subtract based on the signs of the two coefficients. If they are the same, we will subtract. If they are opposite, we will add. But what's important here is to make sure the coefficients are the same numerical value. Okay, when they have the same sign, we subtract. When they have different sign, we add. Then after we combine like terms and solve the resulting equation, we will back substitute into one of the original equation to find the value of the other variable. All right, so let me show you how to do this real quick. So if you look at this particular example, I noticed that the variable x, where the coefficient is already the same, so what I can do is go ahead and eliminate x. I'm gonna write it down here on the side. If the coefficients are not the same, I will try to multiply by a certain factor to make the coefficient the same. In this case, the variable x is already the same, so I can go ahead and eliminate x. Alright, so if I eliminate the variable x, that means the resulting equation will just have y in it. So since the two coefficients has the same sign, to eliminate them, we will subtract the two equations. So it doesn't matter whether I take the top, subtract the bottom, or bottom, subtract the top, the answer will still be the same. So I'm just going to take the top, subtract the bottom, okay? -2x minus and another -2x cancels out. Here we just got to be very careful. -2y minus a -y. -2 subtract a -1y, right? -1y. That will be -1y again. Equals 1 subtracts 3, -2. So if I divide both sides by -1, my answer, y is equal to +2. Okay, so very much just like substitution method, okay? Except in this technique, we will eliminate one variable first, so we will only solve one variable at a time. So once I got my first variable, the back substitution method, now we can sub y equal to 2 back into original first or original second equation. It does not matter. We just got to pick one. I'm going to pick the first one. So that will be negative 2x minus 2 normally times y. Now we will times positive 2 equal to 1. Alright, so that gives me negative 2x minus 4 equal to 1. So since my variable term, negative 2x is negative, I'm going to move over here. So at the same time, I'm going to move my positive 1 back to the left side. So negative 2x come to the right, become positive. On the left side, negative 4 still negative 4. Positive 1 come over, become negative. So I get 2x equal to negative 5. Divide both sides by 2. My answer, x equals negative 5 over 2. So my answer, one solution where the point of intersection will be negative 5 over 2, comma 2. Okay? Alright, that's how we do elimination methods. So let's try several more. So just like before, if I can simplify my equation, I'm going to go ahead and do so. Okay, so I notice my first equation or first line is every term is divisible by 3. So I'm going to say this is negative x plus 1y equal to positive 3. Let's call that my first equation. My second line or second equation, every term is divisible by 5. So I'm going to go ahead and do that. So that gave me negative 2x plus 1y equal to negative 6. All right. So elimination here, I want to make sure the variable I want to eliminate where the coefficient is already the same. So the y and the y has the same coefficient. So I'm going to choose to eliminate y this time. So since the y has the same sign, so that means I'm going to subtract. Alright, I'm going to take the top, subtract the bottom. So that y will cancel out. This is negative 1x minus negative 2x. Sorry, I forgot to write the x right here. Negative 1 subtract negative 2. Negative 1 subtracts negative 2. That will give me positive 1x equal 3 subtracts negative 6. If you don't know that right off your head, that's okay. Right, put it in the calculator, but make sure you say it right. 3 subtracts negative 6. So that will give me positive 9. So right away, x equal to positive 9. So now I'm going to sub my x equal to 9 back into my first equation or second equation. It doesn't really matter. I just pick one. The one looks the easiest. I'm going to go back to the first one. So if I sub my x equal to 9 back to the first equation, remember now the first equation is negative x or negative 1x. So that will be negative 1 times x is 9. Be careful with the sign. Plus the y is equal to 3. So this is negative 9 plus y equal to 3. So y must equal to negative 12 because, not negative 12, positive 12. Because if I move since my y is positive already, I'm going to move my negative 9 over, become positive 9. So 3 plus 9 give me 12. So I get one solution where the point of intersection is 9, 12. All right. Let's try another one. Let's see. So first equation again, everything divisible by 2. So I'm going to do that. Divide every term by 2. That's negative 2x plus y equal to negative 7. Second equation, everything divisible by 2. Excuse me, divisible by 3. So that will be negative 2x plus y equal to negative 7. So right away, what do you see? the two equation or the two line are exactly the same. So if they're exactly the same, that means it's the same exact line. So two lines they are exactly the same means they are intersecting with one another continuously or infinite number of times. So my answer, infinite number solution. Now, if I will continue and if I will continue with this problem arithmetically, let's say I'm going to eliminate x in this case. Let me show you what it looks like real quick. All right, since the coefficient of variable x are exactly the same and they have the same sign, terms with the same sign, we subtract to eliminate. Let's see what happens if I subtract. Negative, take the top, subtract the bottom. -2 subtract -2 cancels out. So no more variable x. But for the y, if you look closely, this is 1y minus 1y, which will also be 0y, or the variable y cancels out. So that means there is nothing left on the left side. On the right side, the equal sign, -7 subtract -7 also cancel each other out. So 0 equal to 0, or left side equal to right side, indicating it's exactly the same. The two lines are exactly the same, which means they intersect infinite number of times. Alright, so this particular example, you can almost see what's going to happen here. If I will reduce every term by 2 for both equations, then my first line will be -2x plus y equal to -6. My second line will be -2x plus y equal to 12. So if I will eliminate my x again or my y, I'm going to write it down here. Eliminate x. Alright, since a variable x has exactly the same sign, same coefficient, to eliminate the x, we will subtract. So if I take the top, subtract the bottom, -2 subtract -2, cancel out my variable x. But for my variable y, 1 minus 1 also canceled out my variable y. So I have no more variable left. So what's left here on the left side is nothing, 0. On the right side though, -6 subtracts 12. -6 subtract 12 is -18. So 0 does not equal to -18. So that tells me the left side does not equal to the right side. Alright, or the two lines actually never intersect because the two lines are parallel. Because if I were solve for y equal, the -2x for both equations will go to the right side, become positive 2x. Same slope, but the y-intercept are different. So that indicates parallel lines, which is no solution. Alright. Let's try this one. Lucky again, because I see the variable y has 0.2 and 0.2 for coefficient. So the coefficient is the same. On top of that, the signs are also the same. So I will just go ahead and eliminate the variable y. Alright, so I'm going to take the top one, subtract the bottom one, okay? Because they have the same sign, we will subtract. So the y will cancel out. 2.6 minus 2.2 is 0.4x equals -7.2 subtracts -25.6. That give me positive 18.4. Divide both sides by 0.4. My answer, 46. So my x is 46. Alright, let's sub x equal to 46 back into Which one looks easier? I'm gonna pick the first one. The first one looks a little bit smaller number on the right side of the equal sign. Substitute back to the first equation, okay? So that will be 2.6 times 46 plus 0.2y equal to negative 7.2. So 2.6 times 46, 2.6 times 46, 119.6 plus 0.2y equal to negative 7.2. All right, I'm going to move my positive 119.6 to the other side, become negative. So negative 7.2 was there already. Now the 119.6 come over, become negative. So that will be negative 7.2 minus 119.6. One too many ones here. Negative 126.8. Alright, so if I divide both sides by 0.2, my answer, negative 634. So that will be my y value. Alright, so this is my point of intersection. Alright, let's do one with a fraction, okay, as the last one. So I demonstrate fraction types before. Whenever we're dealing with fraction type of system of linear equation, the easiest way is to clear the fraction, okay, clear the fraction. So if I take a look at the denominator for my first equation, between 3, 2, and 5, that look like it's about 30. So I'm going to multiply every term by 30. Okay? Multiply every term by 30. So if you're good with this, okay, like I show you how to clear the fraction back in module 9. Alright. Top 30, bottom 3 cancel out into 1 and 10. 10 times negative 5 is negative 50. X. Top 30, bottom 2 cancels out into 1 and 15. 15 times y. 15y equals top 30, bottom 5 canceled out into 1 and 6. 6 times 4, 24. So I'm going to call this my first equation prime because I worked on it one time for right now. Alright, second one, the LCD between 12a and 10. 12a and 10. I know between 12 and 8 is 24. So if you ever have a hard time knowing what the LCD is, I think in Math 106 module 2 we do show how to find LCD with numerical value. So basically I'm going to take my 12, my 8, and my 10 inside this upside down division. And on the outside I'm going to look for a particular number that can go into all three of them, which I can see is 2. 2 go into 12 6 times, 2 go into 8. 4 times, 2 go into 10 5 times. So now I'm looking at 6, 4, 5. Think of a number on the outside that can go into all three of these, other than 1. No, can't find one that can go into all three of them. So let's find a number that can go into any two of these. I know 2 can go into 6 and 4, so I will use 2. 2 go into 6 3 times, 2 go into 4 2 times. 2 cannot go into 5, so bring it down to 5. So now let's think again. Can I find a number other than 1 can go into any two of these? The answer will be no. So that's when I stop. Okay? Because I just have to check. You know, if I only have two denominators, I just got to go all the way down to if I can't find a number going to both of them. If I have 3 denominators, again, I'm going to work my way down to 2 of them. Find a number on the outside to go into any 2 of them. If I cannot find one, that's when I stop. So all the numbers on the outside multiplied together is going to be my LCD. So my LCD, this is 10. 2 times 5 is 10. 2 times 2 is 4. 4 times 3 is 12. 12 times 10, 120. That's what I had in mind earlier. Alright, so I'm going to multiply every term by 120 to clear the fraction. Alright, so top 120, bottom 12 reducing to 1 and 10. 10 times 5x is 50x. Let's see, 8 and 120 reduce 15 times. Right? How do I know that so quick? Because right here, 2 times 2 times 2 is 8. So 8 times 3 and 5 got to be 120. So 8 going to 120 15 times. That's how I know it so quick. So that'll be minus 15y. 10 and 120 reduce into 1 and 12. 3 times 12, 36. Alright, that's my second equation prime. So right away I see if the x has the same coefficient, the y has the same coefficient, just different signs. So if I want to eliminate x, then I must add them. Different sign we add. Negative 50 plus 50 will cancel out. As a matter of fact, 15 plus negative 15 will also cancel out. So again, this problem, I have no variable left. So the whole entire left side is 0. So 24 plus 36 here is going to give me 70. So 0 does not equal to 70. That tells me the two lines will never intersect. Left side does not equal to right side, or the two lines never intersect. So my answer, no solution. Okay, so it turns out elimination methods is really designed for none of the four coefficient is 1. It just turns out our examples here, where I don't have to do a lot of work to see who I need to eliminate. In a different section of this module, I will begin to show you how elimination is truly going to be used, especially when we are dealing with 3 different variables with 3 equations. Okay, then I will demonstrate how we can truly use elimination methods. Alright, that will conclude this lecture video. Thank you for watching.